All right, so area time. So when y'all did your areas, what was the one shape that you all used? Rectangles. What do you think we're going to use to find area under a curve? Rectangles. So now we're going to find the area under the curve of f of x equals negative x squared plus 5 on the bounds between 0 and 2. I want to know how much area is between the x-axis and negative x squared plus 5 between 0 and 2. And I want to be nice and say we're only going to use 5 rectangles. Are they coming?
They're still looking.
I hear their stupid laugh. Okay, so first thing I'm going to recommend you do as you're doing this, until you get used to it, is draw the picture. Alright, so negative x squared, what shape is that? X squared, what shape is that? It's a parabola. Negative means it reflects over the x-axis. The plus 5 means what? So it's going to look something like this. And that this is going to be 5. This is 0. And what is the x-intercept on this? 0, 5. So it's looking like the, what, square root of 5?
Yeah.
Negative 5, negative, yeah, square root of 5. Okay. So we just need to now draw 5 triangles. Now here's the key. One thing that you all had different when you drew your triangles is you all had different widths, right? Like I remember Ryland in that, y'all had some skinny rectangles and then you had some wide rectangles, right? Yeah. Casey and Lily were much better. They made all their rectangles the same width. I'm saying triangles and rectangles.
You're saying triangles.
I'm mixing them. All right, rectangles. We want to keep our rectangles an even width. So if I'm going to have 5 rectangles, these between 0 and 2, how do you think I can find an even width along the x-axis? Take the distance. How would I find the distance on the x-axis between 0 and 2? No. So 2 minus 0, thank you.
Yeah.
Divided by 5, good. Each will be 2/5. You all agree with that statement? That's basic geometry. So then I'm going to have 2/5, 4/5, 6/5, 8/5, 10/5. 1, 2, 3, 4, 5. 10/5 is less than the square root of 5. Okay. Now, Lily, now that you have this, how did y'all attack yours? Because we're going to do an upper and lower bound like y'all did. How did y'all attack yours? Okay, so you drew a triangle that would look something like this. Like this? Yeah? Will this be your lower bound or your upper bound, Casey? This is going to be your lower bound.
So weird.
Right, so y'all did that. And then let's draw the other one then. What? See, when you talk soft like that, it doesn't pick you up. Talk louder. Thanks, Casey. Thanks, Casey. Oh my goodness. Thanks, Casey. Tell him how for the microphone to pick him up. You know, I bought this microphone just because of the pattern, just to avoid all of that talking in the background. And you're telling him to talk louder. It kills your voice. And then the next one you did was something like this, right? Horrible. Just know this is not drawn to scale because this is supposed to be way over closer to the square root of 5. And then this would have been your upper, right? And then what did y'all do? From here, what did y'all do? Find the area of each rectangle and then what? Add them up. Okay, so what letter do we use for add up? Sigma. What's my formula for area of a rectangle? Length times width. So would you agree we have to sum length times width? You agree with that? And then I want to have something like I equals 1, and then what do you think my top number is going to be? How many rectangles do we have? So my top number will be 5. Okay, cool. Let's make length times width a little bit more calculus friendly. Because length times width is just too easy to understand, so we got to make it calculus friendly and make the whole rest of the world not understand it. Okay, so let's call my x-axis my width. Generically, tell me what my width is. From here to here, make it generic for every single problem. From there to there, what did we do? We went from 0 to 2/5. We changed in my what direction? How do we write change in the x direction? Huh? So we're going to say that this is delta x. Cool. Now I have an x value. What is this y value right here? How would I find it? Ooh. You have an equation, and you have an x value, and I'm looking for a y value. f of x, but I'm going to change that to make it f of c sub I, and this is going to be c sub I, c sub I, c sub I, c sub I. So this becomes 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. So we get the different y values. So really, I can actually say an equation for this from 1 to 5, but I could always change that to n, right? If I really wanted to. N is f of c sub I delta x. That's all you're doing. That is your general equation to find the area under this curve to approximate the area underneath the curve. Pretty easy to understand now that you look at this after picking it apart, right? So let's do it. Let's find an upper and lower bound of negative x squared plus 5 from 0 to 2. Where's my erasers? So we're going to sum from I equals 1 to 5 of f of c sub I delta x. Seems easy enough, yes? What was my delta x? What's my change in x? 2/5. Okay, so we can do that. Pull the constant out. What is my f? Could I say this? Can I say this? Because wouldn't this be your first one, then your second one, then your third one? So if I put a 2 in, I get 4/5. If I put 3 in, I get 6/5. If I put 4 in, I get 8/5. Yeah? Okay, cool. So from here, we just plug this. Once I put my I in, this really is just going to be 2/5 times, we are going to do negative 2/5 squared plus 5 plus, what will be my next one? Negative 4/5 squared plus 5 plus all the way up to what? 10/5. Do you agree with that statement? That's the expansion of it. From there, you just basically crunch the numbers, yes? I'll be nice to you. The number is approximately 6.48. Now, which one is that? Is that my lower bound or my upper bound? Which one did I do? Which one did I do? The lower bound. So my area is approximately 6.48 units squared. So we keep adding by 2/5, right? So what's the shortcut for adding by the same number multiple times? Multiplying. Now the upper bound. What's going to change on my upper bound? Anybody have an idea what's going to change on my upper bound? Anybody? Anybody? How am I going to go from this to this mathematically? It's a hard jump, actually. Think in terms of transformations. Where does this rectangle end up would fall on this one? As an increase of what? That becomes here. We shifted everything 1 unit, right? Would you say we shifted everything? Like if we just took this and slid everything over, this rectangle here is now over here and it's above. So there's another rectangle over here, right? That would be shifted over. So how do we write transformations? With the shift moving that direction. Moving right 1 unit. 2/5 times I, the I minus 1. So here you're going to do your F of 2/5. Oh, yeah, that's what I have. I minus 1. And then you do the exact same thing. Yes? Do the exact same thing. Do I need to write it out for you? But we're going to do this a lot more when we get to a thing called Riemann sum, which is the next activity. I really want to just get to the next thing, which is the fun stuff. I just need to get the idea. When we do Riemann sum, this will make way more sense. This is going to be about 8.08. So we know our area is somewhere between 6.48 units squared and 8.08 units squared. And is that not what y'all did, basically? Is it kind of what y'all tried to do? Yes?
Yeah, so we didn't take the average, we had to just find the triangles.
So what you did is you did from here and then you did the triangles.
Yeah, where it wasn't.
Yeah, you try to do the triangles and try to eliminate as much as possible. Right. Okay. So this is kind of like that curve shape thing that y'all did. This is the actual formal math of it. Same idea. Give the area. You could take the average of the two and get a better approximation, but now I'm going to show you how to find the actual area.
We need the function to be able to do these.
You have to have the function. How else would you find the y value? You have to have the function, or I have to give you the y value.
One that we had.
You have to measure it, yeah. But all of those were inspired off of a function. All right, now let's do actual area. This is just approximating. All right, when Casey told me this, okay, if I tell you this was my delta x, right? That ended up being my delta x. What if I wanted a bound from A to B with n rectangles? What will my delta x be? B minus A over n, always. That's always your delta x. Your delta x is always B minus A over n. Always, 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 always. And then always. Here. Now let's actually do a problem. F of x equals 1/4 x squared. My bounds are between 0 and 2. Now we're actually going to find the area of this. Okay? So, what is my delta x? 2 over n. Alright. Now, to find this, all I'm going to do is I need a c, so I have my delta x, I need a c sub I. My c sub I, pick an endpoint and add 2in. Pick an endpoint. Which one do you think is going to be easier? 0. This is basically what that last problem was trying to show, is that these are going to give you the same value as a limit as n goes to infinity. It's going to give you the same exact value. So just pick the easier one to use. 0 plus 2in. Okay. Now, y'all ready to cry when you see the notation? Sure? Here's the notation we're going to do. We're going to do the limit as n approaches infinity of the sum as I equals 1 to n of f of c sub I delta x. That's what we're going to do. Yeah, it doesn't look bad, right? You all know how to do limit as n approaches infinity. You know how to do the sigma. You just have to kind of work it in that order. We found the c sub I. So you have to find the delta x. That's going to be your b minus a divided by n. To find the c sub I, you're going to pick your endpoint. You're just going to add your delta x and throw an I on there. The last example I didn't feel like doing because it's going to waste time. It shows you that when you take the limit as n approaches infinity of your left and your right bound, gives you the exact same number. It's to show you that it doesn't matter which one you pick, that you're going to get the exact same number. I'm just going to tell you that instead of showing it to you to save time. Because these problems take a while. So pick the easy one. Exactly right. That's the whole point of illustrating the other, because I did not feel like doing the 1 minus the I minus 1. I did not feel like doing that because it's literally on my paper. It's all of that work on the bottom just to show you that, what I just told you. Okay, so here we go. Let's find the area of this. First things first is, what does this graph look like? Where's it centered at? Where's the vertex of this parabola at? The origin, is it reflected at all? No, it's just really skinny, right? And then we're looking for this. From 0 to 2, we're trying to find this area. Well, that's horrible. Underneath. We're trying to find that area, right? That's what we're going to do. So now, I'm going to do the limit as n approaches infinity of my sigma equals I equals 1 to n to my f of 2I over n over 2n. Y'all good? Basic plug-in. Now, where can I put this 2n right here? In the front, because it doesn't have the I, we treat it as a constant. So I'm going to do the limit as n approaches infinity of 2 over n to my sigma of I equals 1 to n times, so this is 1/4 of 2I over n squared. What did I do? What did I do? put f and put it into the actual equation. Because this is my x, this is my x, I just put it into my x. Now let's work some math. I got the limit as n approaches infinity. What can I do with this 1/4? Take it out. So I have now 1 over 2n, because they simplify, right? To my sigma as I equals 1 to n of 4i squared over n squared. You good, Elijah? So I did this. I took the 1/4, so I did 2 over 4n and reduced it. Because it is still the same as 2 over n times 1/4. Y'all good here on this one? All right. What constants can I take out of this? What can come out of my sigma? What goes in front? 4, what else? The n squared. So I could say now, the limit as n approaches infinity of, let's see, 4 over 2, so that's giving me a 2 on top, n cubed, right? To the sum of I equals 1 to n of just I squared. Hey, I bet we have a formula for that in terms of n. I bet we have a formula for I squared in terms of n. We do, don't we? Yes, we do. So I still have my 2 times n cubed. What's my formula for the sigma of I squared like this? Was it that? Yes, all of a sudden now my sigma is gone. And now let's start simplifying, huh? 2 goes into 6 3 times, so that's easy enough, right? This cube can become a square and that n goes away. This boils to 2n squared plus 3n plus 1. So let's rewrite this because it's getting a little messy. The limit as n approaches infinity, let's see, I've got 1 times, let's have 2n squared plus 3n plus 1 over 3n squared. What's the limit as n approaches infinity? Come on guys, you should be able to do this one. What's the degree of the polynomial on top? 2. What's the degree of the polynomial on bottom? The limit as n approaches infinity is nothing more than n behavior. If the degrees are the same at the top and the bottom for the n behavior of a rational function, what's the rule? It's the ratio of your leading coefficients. What's my leading coefficient on top? What's my leading coefficient on bottom? So what is the limit as n approaches infinity of this rational function? 2/3. What's the area underneath this curve? 2/3 unit squared. Because that is what you're finding. Does that seem terrible? Lily shook her head, yes.
It's a lot of callbacks.
It's a lot of callbacks, yes. There's a lot of different things going on in one problem. There is a lot of different things going on in the one problem. I 100% agree with you on this. But a lot of this is just, honestly, algebra. A lot of this is algebra. Reducing right here, foiling, finding the end behavior of a rational function, that's all algebra.
We went from 1 over 2 over 2 to
From here to here?
Yeah.
So we did this. 1 over 2n times 4 over n squared. So Y'all need to see another one before I give you one to try? Yeah? Yeah. F of x equals x cubed. I'm going to give you the balance between 0 and 2. Alright, what's my delta x? What is it? 2 over n. It won't always be this, guys. I'm just telling you that. These are the basic examples I'm working. If I had to pick a c sub I, what would I pick? Would I use the 2 or would I use the 0? 0. So I'm going to do 0 plus what? 2i over n. So, I need to do the limit as n approaches infinity of my sum of I equals 1 of n of my f of c sub I delta x. Plug it in. So, let's see. I'll pull it out in a second. So I'm going to have all right. What do I pull out first? The 2 over n, not 2n, 2 over n. 2n is this. So don't pull out a 2n, pull a 2 over n out. All right, what does this become after I do the exponent? Over n cubed. All right, what gets pulled out? The n cubed, what else? The 8. Pull everything out that's not an I. So this becomes 16n to the 4th to the sum of I equals 1 to n of I cubed. I bet we have a formula for I cubed. See what I said? You got to have these written down? Bet we have a formula for I cubed. What's that formula?
N squared, parentheses, n plus 1, squared, divided by 4.
Huh. All right. Let's start canceling again. Basic algebra at this point. Y'all agree? So what is the limit as n approaches infinity of that rational function? It's what? Yep, it's just your horizontal asymptote. Huh, I did it wrong on my paper. 16. Oh. So it's 4. Yeah, my bad. Good enough. All right, so we have 4 minus x squared. We're doing the bounds from 1 to 2. What is my delta x? 1 over n, because it's 2 minus 1 over n. If I have to pick a c sub I, what are we going to do? 1 plus I over n. Everybody good so far? What's actually happening here is, so we have this graph that looks something like this. This is 0, this is 2. right here at 1, we only want this area. That's all we want. That's what we want. All right, let's do this. We need to have the limit as n approaches infinity of my sum as I equals 1 to n of my f of 1 plus I over n, 1 n. All right, what comes on the outside? 1 over n. Let's just plug it in and let y'all see what the dilemma is. Y'all see how much more difficult this just became? Y'all see it? All right. It's just algebra at this point. Your algebra sucks. It's about to get a whole lot better, or you're going to fail this class. It's either your algebra gets a whole lot better, or you fail. Let's see. So I'm going to have n plus I over n squared. Just adding fractions, right? Just adding fractions so far. You could have attacked this a different way, but I like adding my fractions first before I FOIL. What, Philip? What did you just say?
Clipping. I'm making math fun. How I say it is interesting.
I don't have the sign to.
No, you can move anytime you want and get away from Philip. Come over here. Alright.
Oh, you didn't even say
Did he actually leave? He actually left him. I don't blame you. It's Philip.
It's okay, Phil. Come over here.
Let's see, I've got n squared plus 2ni plus I squared. Do not get confused. This I squared is not -1. It's not imaginary. Okay, don't get confused. Just algebra right now. Not doing anything crazy. I know y'all think it's different, but it's just algebra. Everybody good? Does add and subtract fractions? Can I pull anything out yet?
No.
Are you sure? The n squared. I can pull the n squared out now at the bottom, and then now I get I know, right? So we're going to distribute the negative. So I have 4n squared minus n squared. So I have 3n squared, right? Minus 2ni minus I squared. Can I pull anything out yet? I agree. No. Do not pull this 3n squared out. At this point, I need to break my sigma up. That's a horrible signal. Y'all having fun yet? All right, what gets pulled out of here? 3n also. The n squared. So that really just becomes, yeah, let's just pull everything out. 3n squared. 1, right? That's the number 1. The constant. Minus, what gets pulled out of this sigma? That just leaves me my I, which we have a formula for. And then we have my minus. Nothing gets pulled out of this last one. So far, so good? So what does this become? Whenever we have sigma from 1 to n of just a constant, it's just your constant times n. That's the rule I gave you yesterday. So what's 1 times n? N. So this just becomes 3n squared. (3n cubed), because n squared times n is n cubed. So that's n times, because this just becomes, this is an m. So we have 3 times n squared times n. All right, minus 2n times, well, what's I? We have a formula for that. Minus, well, we have a formula for I squared. And we're now rid of all my sigmas. Having fun yet? I'm thinking I'm going to run out of room. All right, let's simplify. This n goes away, this 2 goes away. So that leaves me an n plus 1. But I still have this pesky thing to deal with. Wait, nope. This n does not go away. That's n squared. Because that's 2 over 1. Not to make a huge algebra mistake. Minus, let's just expand this. 2n squared plus 3n plus 1. So this gives me 2n cubed plus 3n squared plus n over 6. Lily's like, I'm so done with this algebra. You still want to write it?
I'll write it.
Wow.
I mean, I stopped writing 6.
Huh? Where? Yes, minus n squared. Oh, we ran out of time. I gotta remember where I finished last week. So let me put a pencil mark on where I finished on this. We are right to here. What? Oh, I solved it differently. All right, guys. See you tomorrow.
You want to take a picture of me?
Take a picture of them, don't take a picture of me.
I'll take a picture.
Did I get one of your class?
What?
Did you ever had a kid in my class?